All right, let's look at number 50. It says on number 50, a child's grandparents purchase a $10,000 bond that matures in 18 years to be used for her college education. The bond fund pays 4% interest compounded semi-annually. How much will the bond fund be worth at maturity? So one thing that I know is that they're going to purchase the bond for $10,000. That's going to be my principal or my P. And then 18 years is going to be my time. And then 4% interest compounded semi-annually is going to be my R and my N. So let's go to the compound interest formula. Now, this compound interest formula is used for any time when you compound yearly, monthly, daily, but not continuously. Continuous is when we have E. So let's go ahead and fill in the information that we know. We know that the grandparents bought a $10,000 bond. So P is equal to 10,000. Then 1 plus our interest rate is 4%. So let's change that until it's decimal equivalent. And then N is the number of times we compound per year. It says we compound semi-annually. That's twice a year. Then you're going to raise that 2 up to an exponent and multiply it times the time. Because we're dealing with money here, your time has got to be in years, and it is. This is going to be an 18-year bond. Okay, so this is my formula I'm going to fill out. Now, let's go to our calculator, turn it on, and we're going to have 10,000 times 1 plus. If you have 0.04 over 2, I'm trying to get closer so you can see that, you're going to have 0.02. So I'm going to simplify that just to make my calculation easier. Then I'm going to raise it up to the 2 times 18, which is 36, okay? So this is my principal, and then 1 plus, this is R over N simplified, and then this is 2 times 18 simplified. Okay, so we're going to go out to 2 decimal places. We're going to have $20,398.87. Okay, so let's go over here. Put the lovely dollar sign. $20,398.87. Okay, so this is how much the bond is going to be worth at 4% interest, compounded semi-annually over 18 years. Okay, now there's another part to this question. We've answered the first part. How much is it worth at maturity? The second part is, what is the effective rate of interest? Well, we have a formula for that, don't we? The effective rate of interest formula takes away the P, leaves you with 1 plus R over N, and takes away the time as your exponent. But it also adds a minus 1. So to find the effective interest rate, we can still do 1 plus our interest rate over 2, raise it up to the second power because we get to drop the T, minus 1. Okay, so let's go back to our trusty calculator, and we'll go 1 plus. Once again, I'm going to simplify R over N to 0.02, and you could have just done 1.02. That would have been actually a better bet for you. And then subtract 1. Okay, and this is going to be my effective rate as a decimal. So what I have to do is move it 2 places to the right, and I'll get 4.04%. So my effective rate of interest is 4.04%. Now, when you're simplifying these things, we all know we can stick all this into our calculator, but if you have something this simple, like 0.04 over 2, and you want to go ahead and simplify that and add 1, that way you can eliminate some of this stuff in the parentheses, do it. But if you're going to make a mistake, don't do it, okay? Only put in there what you can, and you won't miss. Okay, so now we found the effective interest rate. The last part says, how long will it take the bond to double in value under these terms? So let's go back and use our formula again. And we want to know how long, which is time, will it take for our bond to double. Now remember, we started off with $10,000. If it's going to double, that means we have to have a maturity or an ending balance of $20,000. So I'm putting all of this back into my formula. But now we're looking for the time, because we're not looking for the entire 18 years. We are just looking for the time for the bond to double. So when you divide by $10,000, because you're looking for that doubling time, we've talked about this a lot. You get 2, don't you? And then over here, 1 plus 0.04 over 2, that's just 1.02, 1 200ths. And then 2t. I need to get that down, so I'm going to take the natural log on both sides. And that means I can bring the 2t to the front. So let's divide by the natural log of 1 200ths, but I'm also going to need to divide by that 2 that's on the outside. So I'm dividing by 2 times the natural log of 1 200ths. 2 divided by 2 is 1. Natural log of 1 200ths over the natural log of 1 200ths is also 1. So I'm left with t over here. So let's plug this into our calculator and see how long it's going to take for our bond to double. Okay, so looking at our calculator, let's do alpha x. We'll have the natural log of 2 over 2 times the natural log of 1 200ths. Okay, so you can go ahead and tell, because there's a 0 behind in the hundredths place, you can just say 17.5 years. So it's going to take approximately 17.5 years for the bond to double.